Hi students, this is Mr. Werman here. Today we're going to talk about greatest common factor and monomials. So we'll get to that here. Hopefully this combines something that's a little bit new with something that we've done before in the past. Okay, so it's a little bit complicated. Again, we're kind of doing some different stuff lately, some stuff that's kind of at the end of 7th grade is a little bit more complicated, but is preparing you for 8th grade. So, if it feels challenging, that's okay. Just kind of stick with it and stick with us so that we'll get there, all right? So, today we're going to, again, find the greatest common factor of monomials. So you should have done the warm up, and now you're up to the video here. So yes, if you have headphones, please plug those in as you watch these videos here. All right. So first of all, we'll go over the definition of what a monomial is. So a monomial, this is in your book as well on page 416 if you wanted to follow along. So a monomial is a number, a variable, or product of a number and one or more variables. So examples of monomials are going to be like a number like, as they say, 25 here, a variable like x, or a product of a number and one or more variables. So that's like 40x, right? 40 times x, 40x. Okay. So other examples could be things like 17, 36x. We can have other variables as well, 25a. So those are all examples of monomials, all right? So again, we have a either a constant, a variable, or a coefficient with a constant together, okay? So not monomials are going to be things like we have been doing, which were linear expressions, all right? Things like x plus 4, 4x plus 120, all right? 3x minus 2. Those are all examples that are not monomials, more linear expressions. All right. So factoring, what is factoring about? Okay, so we've done this, you've done this in the past, but maybe we need a little review of this. So when you're looking at a factor, to factor something, it says to factor a number means to write it as a product of its factors. Okay, so what are the numbers that multiply together to make that number? Right, we say factors are few, multiples are many. So multiples are how you multiply a number out. Factors, how many numbers really divide evenly into that number. Okay. So when we're doing our factors here, we're going to do prime factorization often as well. So we're looking for our factors. When we find the greatest common factor of two monomials, we find that factors of two monomials, we're looking for the greatest common factor. Okay. So let's actually look at some examples here. Okay. So let's just start with basic GCF for a second before we get into the other ones. All right, greatest common factor abbreviated as just GCF. All right. So for example, if we have 12 and 16, right? We're thinking, what are the common factors of 12 and 16? Well, how we're going to do it here, we're going to deal with, there's two different ways to find this here, but we're going to work on just using prime factorization because that helps as well. So prime factorization. So we're thinking, what are the prime numbers that go into 12? So let me do a quick maybe factor tree. I think that's probably the easiest way to do that with 12. Start with 12 here. Okay. So think of our prime numbers that go into 12. This looks familiar. So we know 2 is a prime number. Again, a prime number is a number with only 1 and itself as a factor. So 2 is a factor, a prime factor. And we say 2 times 6 is 12. So I'm going to write 6 over here. But 6 is not a prime factor. So we can circle this. This is a prime factor. 6 is not a prime factor because it's even. And 2 is the only even prime factor. Prime number. So let's look at two numbers that multiply together to be 6, like 2 and 3. Okay. 2 and 3 is 6. These are both prime factors. So go ahead and circle all those. All right. I've got all my prime factors now. So if I were to take 2 times 2 times 3, excuse me, I would get 12. 2 times 2 is 4. 4 times 3 is 12. So yes, 2 times 2 times 3 is our prime factor here of 12. So I'll go and write that out. 2 dot 2 dot 3. All right, 16. Okay. Again, easy prime factor to start with. If it's even, is 2. So 2 and 8. And then 2 also goes into 8 as well, which is 2 times 4. And then we have 2 times 2 being 4. Okay, does this look familiar? Hopefully a little bit. It may have been a while since you've done this last. So these are all prime factors, 2, 2, 2, and 2. So we can circle those. We've got all of our primes. All right, let's multiply them all together. 2 times 2 is 4. 4 times 2 is 8. 8 times 2 is 16. Sure enough, that is correct. All right, so we could write that as 2 to the 4th power. For our purpose here today, we're just going to write 2 times 2 times 2 times 2. All right, we can look at these two numbers and see our greatest common factors. We've got a pair of 2's. We've got a pair of 2's. So what is the greatest common factor of both 12 and 16? Well, they both have 2's, a pair of 2's as greatest common factor. So 2 times 2 is 4, right? So 4 we know must go evenly into both 12 and 16. All right, so the greatest common factor is 4 of 12 and 16. All right, does it look familiar? All right, I think we'll be good on our basic examples of GCF. And let's move on to I forget how to do this. Okay. Let's move on to some examples with monomials. All right. So let's look at two monomials here, 4x and 12x. So when you're doing linear expressions, you are dealing with these as well, right? Things like 4x and 2x. We know if we were to add these together, it'd be 16x. But that's not what we're trying to do today, okay? We're looking for greatest common factors. Okay, so 4x and 2x. If we write out, just like before, we could always do a little factor tree with our numbers, right? We know, as we said before, 2 times 2 is the factor tree for 4. For 12, we could do 2 times 6, and then 2 times 3. Okay. All right. So we see with our sets of these, right, we know 2 times 2 is going to give us 4. 2 times 2 times 3 is going to give us 12. And of course, they're both being multiplied by 1x, right? So I say 2 times x is 4x. 2 times 2 times 3 times x is 12x. Okay. Hopefully we got that. So we're going to circle, just like we did before, circle our common factors. We see we have a set of 2's and a set of 2's. So again, 2 times 2 being 4, there's a common factor. And they both also have this common factor of an x. So the greatest common factor of this set of monomials is not 4, but 4x, right? So in other words, I could take 4x. We know 1 times 4x is 4x, because all those together, right? And we know 4x times 3 is 12x. Either way, this common factor of these both is 4x. Okay? Looks weird. If you're feeling lost, just again, don't give up. New stuff is challenging, but that's what makes it so fun. All right, let's look at another. Oh, okay, there we go. All right, let's look at another example here. We have 18a and 20ab. All right, like before, we could do our prime factor tree out. I'm going to kind of skip that point a little bit, but if we do it out, we'd see it's 2 times 3 times 3. Okay, we can double check. 3 times 3 is 9. 9 times 2 is 18. Perfect. And we're multiplying that all times a. All right, so if we look here, we have for 20, we have 2 times 2 times 5. 2 times 2 is 4. 4 times 5 is 20. That works out. And then we have an a and we have a b. All right. So we've factored these out using prime factorization. We see our common factors here are 2 and a. So what is the greatest common factor, or GCF, of 18a and 20ab? 2 times a, or in other words, 2a. Okay. another. Again, these examples they do out for us here. So we have 12 CD and 36 CD. All right, common factors. We see both the CDs are common, right? That one should be obvious. And then if we factored out our 12, we get 2 times 2 times 3. 2 times 2 is 4. 4 times 3 is 12. Yep. This one we have 2 times 2 times 3 times 3. Again, 12 times 3 is 36. So our common factors are a 2, a 2, a 3, and the C, and the D. So if we multiply them together, 2 times 2 is 4. 4 times 3 is 12. 12 times C times D, we have 12 CD. All right. Okay, I know it's crazy. It's weird. It's new. We'll do it though. We'll be all right. All right, so let's try a couple here. These are on page 416 in your book. So either do this in your notebook now or have your book open to page 416 and you could do it there. All right, let's write these out. I'd like you to kind of pause the video if you can, take a minute and try it, and then come back and check. But I'm going to start walking through these now, okay? So we have 12 and 28C. Right off the bat, we should notice one has a variable, one doesn't, okay? They both don't have a variable. They both don't have a common variable, okay? So that's not going to be a common factor of these two. But let's look at our numbers. All right, so let's start with 12. I'm going to do a little factor tree. Even though we've kind of done 12 a couple times here, we could probably do it without the tree. I'll just do it for longhand. Again, why don't you do this in your notebook right now or in your book if you haven't already done so. Okay, we have 2 times 3 times 2, okay, is 12. So our factors here of 12 are 2 dot 2, oops, I wasn't sure, that'll be 2 dot 3. Okay, and then 28. Okay, again, 2 times 14. Just start with that even one, make it easy. And then 14 divides into 2 and 7 evenly. 2 times 7 being 14. So we have 2 and 2 and 7. So we're going to say here 2 times 2 times 7. And then we have our C. Okay, great. We can double check it. 2 times 2 is 4. 4 times 7 is 28. 28 times C is 28C. Perfect. Okay. So what are our common factors? Well, we see we have a pair of 2's here. And we have a pair of 2's here. 3's are different. 7's different. C is different. So what is the common factor or the greatest common factor of 12 and 28? Yes, 2 is a common factor, but the greatest of those is going to be 2 times 2. What's 2 times 2? Yes, of course, we know that, 4. So the greatest common factor of 12 and 28 is 4. Okay? All right, let's look at another one. I'll go ahead and delete this for space-wise. All right, we have 25x. Again, you should pause the video, try to do it yourself, and then come back and check. 15x All right, I'll kind of skip the factor tree on this one because this is pretty simple. All right, think of the numbers that are prime that go into 25, or any numbers that go into 25. If you're stuck and you're looking for a prime number, just go with any number and you can break it down to a prime number eventually. But in this case, of course, 25 is only the factors besides 1 in itself is 5 and 5. So we have 5 times 5, and then, of course, we have an x. All right, great. These are little colons. It's hard to make a little dot on this with this pencil. All right, 15. Factoring 15 out, we see 3 times 5. 3 and 5 are both prime numbers, right? Nothing goes into them. So that's it. That's our prime factors here. 3 times 5. And then like before, we could say times x and times y. All right. Wonderful. What are our common factors or our greatest common factors of 25x and 15xy? let's look closely. We see, yes, of course, a set of 5s, okay, and a set of x's. That's it. So what is the GCF of both 25x and 15xy? 5 times x, 5 times x, so it's just 5x is that GCF. Okay? All right, let's look at one more. Hopefully you have it done. You know that's what I'm going to ask you. So I'll go right into it. We have 42 mn, and 14 mn. Okay. All right. Let's look here. Common factors of 42 mn and 14 mn. All right. I'll have to do 42 out here. Just a little bit longer. Okay. Again, I like to start with an even number, but you don't have to. You can start with 6 and 7 and break it down from there, but I'm just going to go with 2 and 21. Okay. 2 times 21. Factors of 21 include just 3. So 3. Sorry, my writing is sloppy. And 7. Okay. 7 doesn't have any factors besides 1 in itself. Neither does 3 and 2. So we found our prime factors of 42m. So again, it's 2 times 3 times 7 times m times n. Okay. Let's look at 14. Do a quick prime vector tree. 2, 7. Again, 7's prime, 2's prime. We're good. We have 2 times 7 times m times n. There we have it. Common factors, 2, 7, m, and n. Okay, so what do we have? We multiply it all together. 2 times 7, 14, times m times n. Our common GCF of those two is 14m n. All right. Cool. All right. Again, it's new stuff. So kind of our procedure here. Factor them out. You can use a prime factorization tree. There's other methods as well. You can just write them out, but I think the factor trees are very visual, help us to make sure we get those all. Okay. Once you have it factored out, we're just looking for things that are in common. That's all. Okay. If you didn't, hopefully you tried those 3 with us as we went. If you didn't, make sure you get those down in your books or in your notebooks. That was page 416. And then you all should be completing 1, 2, 3 of the guided practice there and any other problems we list in classroom. Okay. That would be on page 418. All right. Hope that's helpful. Hope that made sense. And let me know if you have questions. All right. Have a wonderful day.